Hey, hello, and welcome to today's system design session. So today we are going to see design URL shortening service. Okay, and first of all, what is URL shortening service? What is the role of what is the responsibility of URL shortening service? So given a long URLs, right? So when what does the URL shortening service do? Long URLs is the input, right? Long URLs is the input to this URL shortening service. And what output it gives? Short URLs. So long URLs basically are URLs like if you can see in this example, right? So this is a very long URL, right? So long URLs are tedious to like they are very big and they are not very easy to share, right? So there are some services which provide service like given long URLs, they provide short URLs, right? Which are easy to remember. How now? What are the example of short URLs? You can see the example of short URL here. tinyurl.com/jlg8zpc. Okay. So what? For example, if this URL shortening service gives you this, right? tinyurl dot com, right? And this jlg8zpc, right? In response it gives you this. So now from next time you don't have to type this long URL, right? In the browser, you can just pass on to this small URL here. Okay, and it will redirect to this URL. Basically, it will redirect to this URL page. Okay, so this is the responsibility of URL shortening service. This is the advantage of URL shortening service. It gives you short URLs for your corresponding long URLs, and then you can use them whenever you want to route to that page, right? So this is the job. And there are quite a few services which provides this. Like one of them is tinyURL, one of them is bit.ly, and one of them is Google's own goo.gl. Okay, so now this is the problem we want to design the system for. Okay, this is the problem we want to design the system for. So whenever an interviewer asks, right, any system design problem, so what should be the approach? How should we uh, uh, design the system? Okay, so the first and foremost thing is we need to understand the functional requirements. Functional requirements. Then second is we'll come to this. What is functional requirement? Then second is non-functional requirements. Third is scale estimation. Now, what is scale estimation? Scale estimation is like how many requests are we expecting per month? What is the load of the data which is going to come, right? What would be the storage which will be required to store this data, right? And how much that there should be the scale of our services, right? Of our system to handle the data which we are expecting. Okay, we'll come to this in detail. Then once we get these details, right? Once we get these details, right, then we can design our system. For example, we can design the API. Design APIs. We need to figure out which APIs we need to expose by a system, right? So that the users can use these APIs. Then fifth would be database design. Sixth would be our high level system design, right? What would be the flow of what would be the services which will be involved, right? The flow diagram we have to draw. And what would be the business logic? How are you going to solve a particular problem? So high level system design, right? In this you have to draw the flow diagram basically, like the services involved and the DBs involved, all this stuff, right? So whenever a system design problem is asked by the interviewer, so we should proceed in you should keep in mind these particular steps, right? Once, for example, as interviewer asks that design a URL shortening service, then we should be asking the functional requirements to them. What are the functional requirements? You need to understand first of all what is this, what is the problem which we need to solve. Then we need to ask the functional requirements. What would be the functional requirements? What would be the non-functional requirements? What would be the scale estimation? And based on this, then we have to design the APIs, database design, right? How much storage is needed, and then high-level system design, how many instances of the services or whatever architecture we use, microservice architecture and all. What would be the number of services which will be required, right? So let's go to the first step. Let's go to the first step, that is functional requirements. Functional requirements. So we need to confirm this or ask this to the interviewers or to the interviewer. Okay. So the first and foremost question would be like if it is URL shortening service, right? So what our system or service should do? This is the main and basic functionality. Given a long URL, given a long URL by the user, the service, the URL shortening service should return a small URL, right? Then the second functional requirement. These are the functionality, right? What functional requirement means? What functionality we need to provide by a system, right? Then second, given a tiny URL which was already created by a system, a small URL basically, our system should return the original URL to the user. Original URL to the user with redirection, right? With redirection to this original URL page. Okay. Okay, so these are the two main functionalities, two main functional requirements which our system should provide. Then second can be like you must have observed, right? So there was this in the example, there was this tiny URL hyphen JLB6CE, right? So this is the small key, right? This is the unique identifier for the URL which was provided, for the long URL which was provided by the user, right? So this is the small key which is the identifier, or right, which is the identifier for that long URL. So this is generated by a system, or it can also be provided by the user saying that okay, I don't want your system to generate the short key, but I want to give my own key. So that also should be the provision for the user. So user should be able to provide his own custom key, right? His own custom key. The custom key, as I said, it will be like this, right? And also whenever we create a custom key, a short URL for the user, definitely it will have some expiration time, right? For example, we may store that tiny URL for 5 years in a system, right? Post that it will be expired, right? So there should also be provision for the user to provide its own expiration time, able to provide his own expiry date or time, right? Or time. So these would be the functional requirements, right? Our service or our system should provide the functionality, right? So this was the first step. Then second would be, which is again part of requirement only. Second would be non-functional requirements. So what it would be? First would be that our system should be highly available. Highly available. So when we say our system or our service should be highly available, right? So there should be no downtime whenever a user provides a long URL. So our system should always be up and running to provide the short URL, or given a short URL by the user, our system should always be able to redirect to the original URL. Okay, so our system should be highly available. This is the one of the main requirements of the non-functional requirements. Okay, the second would be there should be minimum latency. There should be minimum latency. In either creating a short URL or redirecting to a long URL, right? So there should be minimum latency. Our service should be quick enough to return a short URL to the user or to redirect to the original URL, right? Right. So these are also main functionalities of our system, right? If this is not available, right, into a system, then the user experience would be very bad. So that is why we should keep in mind that a system should be adhering to these requirements, right? So third would be the scale estimation. We need to ask to the interviewer, right, what is the scale of data? Scale estimation, right? So let's say the interviewer says, okay, there would be 500 million URL shortening requests. There will be 500 URL shortening requests per month, right? So per month into our system, there will be 500 million URL shortening requests. That is 500 million long URLs will be provided, and our system should be able to provide the short URL, the corresponding short URLs, right? And this is the right? This will be the rights, right? Into our system. And the reads, let's say the interview says that there would be 100:1 ratio, right? 100:1 ratio, read to write ratio per month, right? So let's say if it is, so if there are 500 million requests per month, right? Million requests per month. So there will be 500 million into 100, okay, into 100 reads per month, right? Into 100 reads per month, okay. So this will be the huge number, right? This will be the huge number. So when we say reads, right? So there will be like the user will be providing these many requests, lot of users, right? Millions of users would be providing these many requests, right? Will be providing these many short URLs to be redirected to the original long URLs, right? So these would be the estimates, this will be the estimates which will be given, which is given by the interviewer, right? Now when this data is given to us, so right, so what all things in the scale what all things we need to estimate, right, according to the scale. So the first and foremost would be the traffic estimate, right, which would be like uh, if it is 500 million requests, URL shortening requests per month, then what would be per second? So what per second traffic are we expecting, right? So what it would be 500 million divided by per second we want to calculate, right? We always have to calculate whatever the traffic estimate or whatever the scale estimate, right? We need to calculate per second. What would be the per second estimate, right? So 500 million per month. That means per second, if you want to calculate, divided by 500 million divided by 30, right? Considering 30 days in a month, right? Divided by 24 hours in a day, divided by, right, 60 minutes divided by 60 seconds. This will give us per second number of requests, right? Per second request. So approximately it comes around 200 requests per second. So there will be 200 URL shortening requests per second will get to our system. So our system should be should be strong enough, should be robust enough to handle these many requests per second. Okay, so this would be the scale. And what would be the, this is the right scale, right? This is the right scale. That is the 200, there will be 200 long URLs which will be provided per second. We need to provide corresponding short URLs. Okay, and what would be the reads, right? So considering 100 is to 1 ratio, right? 100 is to 1 ratio. So it will be 20 into 100, right? If there are 200 requests per second, then reads will be 20 into 100, that is 20k reads per second. Okay, so our system should be robust enough to handle these many writes and these many reads. Okay, so this would be the traffic estimates. Writes should be 200 requests per second, reads will be 220k 20,000 reads per request per second. Okay, then coming to the second estimate which we want to calculate would be um, storage estimate, right? Storage estimate. So what would be, how much storage will be required to store like 500 million, right, requests per second, sorry, 500 million requests per minute. And let's say our default storage span for a particular URL, right, for a particular URL would be 5 years. That is, we'll be storing the data for 5 years for any given URL, right? So considering 500 million per month, right, and we want to store this data for 5 years, so it would be 500 million into 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 12 months, right, and into 5 years, right, into 5 years. So it would come around how many URL data we will have to store. It comes around 30 billion. For 5 years we'll need to, our system will need to store 30 billion URL data, right? 30 billion, right? Considering five, if we are getting 500 million per month, if we are going to store for 5 years, then it will be, each month we'll be getting 500 million, right? So we have to store for 5 years. So it will be 30 billion. And what would be the, considering each URL data, right? Whatever the short URL which will be generating, the short tiny key will be generating, and the long URL which will be storing, and the other user metadata, right? Each URL data, right? If we consider each URL data to be 500 bytes, 500 bytes, right? Each URL data to be 500 bytes. So how much it will be? 30 billion into 500 bytes, right? So how much it will be? How much it will be? 15 terabytes of data. So we'll be requiring 15 terabytes of minimum storage. Okay, 15 terabytes of minimum storage to store all the load, all the data which you'll be getting. 500 million per month, and 5 years you have to store, right? Each month you'll be getting 500 million data. So you'll be requiring 15 TB of storage. So this is the storage estimate which we have estimated. Then third comes bandwidth estimate, right? Bandwidth estimate. So in each request, how much data is coming and going, right? If we consider writes, how much writes we had calculated? 200 requests per second, right? So considering each request having 500 bytes of data, as we had calculated, right? 500 bytes of data. So 200 into 500 per second will give you 10 KB per second of data will be coming into a system. That is, writes will be 10 KB per second of bandwidth, right? So 10 KB. So 200 requests per second, and each request having 500 bytes of data, it will give us 10 KB per second bandwidth. Our system should be able to handle. And what would be the reads? Right? Reads would be, if we consider 20k, right? 20k requests per second we are considered, right? So each request will, our system will be providing 500 bytes. So which will be nothing but 10 MB per second data will be getting per second. For reads will be like, there will be 10 MB per second of data which will be flowing through the network, and 10 KB per second of data which will flowing for the writes. Okay, so this is the bandwidth estimates. Now coming to memory estimate, right? Now coming to memory estimate. right? Coming to memory estimate. So let's say now right. So what we want to do is we want to cache some of the URLs, right? So whenever there will be, for example, right, for example, there's a short URL provided by the user, right, to our system, right? And our system will, what will be providing original URL, sorry, redirection request, redirection with original URL, right? This is what is expected, original URL, right? URL shortening service, right? So let's say if a user has provided the short URL, and our system will be returning the original URL in the response, right? So it should be very fast, right? Our system should be, there should be minimum latency, as we have discussed earlier. So if you want minimum latency, so what is the best storage, right? What is the best storage? So the best storage would be the memory storage, in the memory, right? In the RAM, in the RAM. So you must be, definitely you must be knowing that the reads and writes whenever are very fast to the RAM, right? So what is called, when we say memory storage, we would be caching the data. We're caching the data, right, into the memory, right? So if you want to provide fast service with minimum latency, so we need to store some of the data into the memory, so that the original URLs which will be providing will be served faster, right? So we need to cache or right or store the for example the URL, the short URL, right? Whatever short URL, JLZKEC, right? If this is short URL, and what would be the mapping? Let's say the mapping would be educative .com and blah blah, some big URL, right? So we want to store this key value into our cache, into the memory, right? So whenever there's a short URL which is provided by this user, we will provide this value faster from the key. So this would be on a high level. We need to store this in the memory, right? So considering the 80-20 rule, right? 80-20 rule of caching. So what does it mean? So 20% of the traffic, right? So for example, 20% of the URL, right, of the short URLs generate 80% of the traffic. So there'll be there'll be, this means that there'll be 20% URLs which will be providing most of the times 80% of the traffic. That is, in a day, if we consider, for example, there is a short URL, right? So that short URL itself will be like there may be some users, right, which will be always using these short URLs. The frequency of using these short URLs to redirect to the long URLs would be very much. For example, if a user, there will be 1,000 times the user will be providing the same URL, the same short key to be redirected to the long URL. So considering that 20% of the URLs will be generating 80% of traffic, right? Of short URLs generating 80% of the traffic, right? So we'll be getting 20K requests per second, right? The read requests per second, 20K read requests per second. Now what we want to do is we want to cache consider per day's data, right? So we want to cache 20% of this request. So 20%, right, of 20K, 20,000 requests per second, right? And we want to, like this is 60 into 60, right? This will be giving us per hour into 24, right? So we want to cache all this data, right? The 1 day's read data we want to store into a memory, right? So first of all, if we consider 20,000 requests per second, right, and we want to store 20% of this 20,000 per second, because 20% of the days, right? 20% of the days read data, right? So if we consider 20,000 requests per second, right, this is per minute, per hour, and this 24 hours in a day. So we want to cache 20% of the read data, right, of the read data, of the read traffic into a cache. So this comes around 1.7 billion per day, right? 1.7 billion per day uh, request, right? And what would be 1.7 billion per day into, if we consider 500 bytes, right? If we consider 500 bytes of data, right? So there will be 1.7 billion URLs, right? Right? And 500 billion. So this will give us 170 GB. 170 GB of data we need to cache. 170 GB of data we need to cache into our memory. Okay, into our cache. Okay, so our cache can be, we can use, one can be Redis, right? Redis, it's a distributed caching system or service, and other can be memcache. Okay, we can use this one of either two. Okay, so 170 GB of memory will be required, okay, to store 20% of the traffic. Okay, so these were the scale estimation, right? We have seen traffic estimates, we have seen storage estimates, we have seen bandwidth estimates, and we have seen memory estimates. Now, since we have got the requirements, right? We have seen functional requirements, non-functional requirements, scale estimation. Now we have all the data. What we need to do, right? How the system we need to design. So let's now design uh, API, APIs, which will be exposed by a system which the third-party user can use, which the users can use, right? Design APIs. So one API can be what? One API would be create URL, right? Create URL, right? Right. So, for example, create URL in the sense what it will do is, uh, yeah, what it will do is the user will use this to um, uh, the user will give the long URL, and in the response it will give the system will provide the short key, right? The short URL. So create URL. So first param can be API dev key. Definitely, each user will have his own unique identifier, right? Which will be API dev key. Okay, it's an own unique user identifier which the system will authenticate the user using this API dev key, right? And then what will be the second parameter? Original URL. Original URL, right? Original URL for which the user wants a short URL. Okay, third would be custom key, right? If for a particular, if a user wants his own custom key to be used, right, to generate the short URL, right? And then custom expiration time, expiration time, right? So this will be one API. The second API can be delete URL, right? If a user wants to delete the URL, just create. So again, what will be the API dev key will be one of the parameters to authenticate the user, and the second would be the short URL which the user wants to delete, right? Which the user wants to delete, the short URL which was generated by system. Third would be uh, get original URL, right? Again, this would be API dev key and the short URL, right? The short URL, as a user wants the original URL in response, right? So these would be the APIs on a high level, right? Which our system should design, right? Should implement, and should expose to the users. So these were the APIs. Then what we need to design? The next step would be database designing, right? Database designing, right? So what schema we would be required, right? On a high level, if you see, right, the two tables which will be required would be, one would be the short key, the key, right? The key which we saw, right? Tiny URL, right? Tiny URL and JKLECA. So this was a short key, right? So this should be the unique identifier, right? Okay, so we can say hash key, for example, hash key, right? Let's say its length maximum would be 16. 16 would be the maximum length of the hash key, and then this would be the primary key of this table, right? Primary key, right? And what all other columns will have? Will have the corresponding original URL, right, which will be stored into this table, right? And what will be the creation time? When was this short key? When was this created, right? And then uh, there would be expiration time, right? Definitely there will be expiration time for each URL. So expiration time. So what is the default year by the system? 5 years ago, right? 5 years as we saw. And then which user created this key, right? Short key, or for which user the system had created the short key, right? And then we'll have the user metadata table as well, right? User metadata table as well. So user ID would be the primary key, right? And then username will be the column. Then email ID, email ID. Then creation, right? Creation uh, date, right? Right. And last login. When was the user last logged in? Last login time, right? So on a high level, our system will require um, to have these two tables, right? To have these two tables to store the data, right? Now, what kind of data base we should be using, right? Right? What kind of data should we be using? SQL or should we be using NoSQL, right? NoSQL. So considering the scale of data, right, which our system should store, so it is going to be huge data, right? As we saw, for 5 years we need to store 30 billion records, right? 30 billion records, right? Considering 500 million per month, we need to store for 5 years, so it will be around 30 billion. So it is going to be huge, right? So we'll have to go with NoSQL database as the scaling, right? As a scaling, if the let's say if our system is thriving, right? Now earlier we were expecting 500 million per month. Now all of a sudden, now a lot of users are using our system, our service, and let's say 700 million or 1 billion per month requests we are getting, right? So in this case, so NoSQL databases can be scaled easily, right? Can be scaled easily. For example, let's say considering 500 million the requests we're getting per month. So we were having hundreds of nodes of database, right? So now the estimates like a lot of users have come in. It is 700, 800, and 800 million requests per second. So we can easily add additional nodes. We can easily scale our system from 100 nodes to maybe 200 nodes. So this is easily done in NoSQL, right? So we will have to go with NoSQL databases. In this case, we can use Cassandra databases, Cassandra NoSQL database. Again, it is a NoSQL database, or DynamoDB, right? We can go with these with such kind of databases, wherein the scaling of the databases is easier. Okay, okay. So this was the high-level database design. Okay, now let's design the system. Let's design the business logic, right? Let's design the business. The main heart of this, right, would be to generate the key, right? So for example, a long URL is provided, right? To our URL shortening service or system, I'm going to provide the short URL, right? Now, as we saw, right, tinyURL, what the short key was, or the short URL, the short key was JKL, something like that, right? ECA. It was something like that, right? 6, right? So, how are we going to generate this unique identifier for each URL, right? How are we going to generate? So, this is the main heart. This would be the main heart. How are we going to generate this key, right? This key, right? So, we'll discuss this first. Okay, so what one approach can we do is, for example, um, uh, if a long URL is provided, right, by the user educative.com and blah 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 blah, right, long URL, right. Now what we can do is, we can, one approach can be to use MD5 or SHA-256, right, to hash this URL, to hash this URL, right, to hash this URL. But still, if we, even if we use such this algorithms, right, MD5 or SHA-256 to hash this URL, it is still going to generate 128 bytes, right, which will be a very long, which will be a very long key. We don't want, we want at the max 16 bytes of key, right, at the max 16 bytes of key. Even if we encode this, even if we encode this 128 bytes with base 64, right, it will, there will be still 128 bytes, right, 128 bytes. If we do base 64 encoding, it will still give us max 21 bytes, right, which is, which is still big. We want at the max 6 bytes or 8 bytes, or 8 bytes, right, we can generate, right. A short key should be sufficient for us. We don't need this much, this big, right. Okay, so considering, right, considering the base 64, base 64, right, base 64 encoding. So if we consider 6 characters or 6 bytes of key, right, so how many short keys, or how many keys, 6 byte keys would be generated if we do base 64 encoding, right, and consider 6 characters? It would be around 68 billion keys, 68 billion keys. Okay, and if we consider 64, 8 bytes or 8 characters long, it would be around, I think, I don't know, maybe 120 trillion keys can be generated. Okay, so I think for our system, right, this 6 character or 6 byte key should be good enough, considering 68 billion keys we are going to get, right, as, and we saw that our system will be requiring 30 billion, right, for 5 years to be stored, right, 30 billion keys or 30 billion URLs, our requirement is this much, right. So 68 billion keys would be sufficient enough for us, right, right. So it will also take, if we use six characters long, right, it will also take less amount of space into our database, right, considering 8 bytes and 21 bytes, something like that, right. So we saw that, right, even if we use the big URL, right, to hash, like using MD5 or SHA-256 to hash this big URL, so it is still giving a lot of big right number. 21 bytes is big number. So what can be the approach to generate 6 character, right? What can be the approach to generate the 6 character key, right? 6 character long key, right? So what we can have is, we can have a service called key generation service. Key generation service, right? It will generate offline, right? 68 billion keys, right? 6 character keys, right? Using base 64 encoding, right? So it will generate and store it into, it can store it. We will have this key generation service which will store this 68 billion keys, right, into KeyDB, into KeyDB. So it can do in the background, it can generate these many keys, 68 billion keys, any random keys, right, any random 6 character keys, and it can store in the KeyDB, right. And then our system can use, right, can look up into this DB to fetch the any short key, any random short key, and then can provide to the user that short key against the original URL. Okay, so yes, so we'll be using our own service, key generation service, which will generate the random 6 character keys and will store into our KeyDB, right. So this will be the business logic. Now coming to the high level flow diagram, right? Coming to the high level flow diagram, what we can do is, we can keep the writes and reads separate, right? So that um, there will be minimum latencies, as we know, right? The writes, generally the writes, the short URL generation would be slower than the reads, So why why to delay the read request, right? So we saw that there will be 200 requests per second of writes, right? Of writes, and there will be 20k requests per second, 20k requests per second for reads, right? Right. So if we have a same service, a same flow, the same set of services, so it may impact the reads, right? It may impact the performance of the reads. So what we can do is we can have separate flow for reads and writes. So we can see through the um, through the high level diagram, right? So what it will be first? First will be the API gateway. API gateway, which will be exposed to the outside world, right? The user will be communicating to this API gateway. API gateway will be used for authentication purpose, for redirect, for routing the request into the backend, right? So API gateway will be exposed basically. So what we can have is we can have a write flow separate and the read flow separate, right? So yeah, so coming to the flow diagram, we'll have API gateway, right? The API gateway will identify whether it's a write request or read request. Then accordingly, what if it is a write request, it will pass to the URL shortening service. URL shortening service, right? And what the URL shortening service will do, it will query the key, the short key which it wants, right? To shorten the URL, right? So it will query the key generation service. It will tell the key generation service, hey key generation service, give me the short key. Please give me the short key. I want to give the corresponding short key to the long URL which is provided by the user. And what will be the key DB will do? It will fetch from key DB, right? The key DB. It will fetch from key DB, right? And it will give the short key. Now, what we can do is the key DB. Okay, we can discuss this now. The key DB can have further two tables, right? Unused keys and used keys, right? So whenever a key generation service picks up from the unused keys, as the name says, right, these keys are not used yet, okay, the key generation service will pick the unused key from this unused keys table, and then it will immediately put it in the used keys, right? That means this table will have all the used keys, okay, which cannot be used further, as these keys are already booked for some users. So it will take the unused key, it will store in the used key, and will return that particular key to the back to the URL shortening service, which the URL service shortening service will provide to the user. Like it will pass on to the API gateway now. Okay. So this will be the write flow, and what can be the read flow, right? So the read flow can be, right. The read flow will be, right, the short URL, right, something URL fetcher, right? URL fetcher, okay, or yeah, URL fetcher, okay, some URL fetcher kind of service will have. And what it will do is, first it will, as we said, right, it is going to cache, right? So once, for example, so yeah, so what it is going to, so there will be some URLs, right? Some kind of URL, right? As you said, right? If the user has passed tinyURL, tinyURL, URL slash JKL6E3C. This was a short key which is provided. And in our cache, how this will be stored? We'll have a corresponding short key JKL6E3C as a key, and the corresponding value would be the original URL, right? Original URL, which will be nothing but educative.com, blah 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 blah, the big URL, the long URL. Okay. So this particular mapping, right, of short URL to long URL will be stored in the cache, in the memory. So this URL fetcher service, it will first check in caching in the cache whether we have this key or not, the particular this key or not. If it is there, then this the if it is there, if it is present, right? So we'll return this long URL to the user directly from the cache itself, right? As we found in the cache, it will be very fast. If it is not found, for example, if it is not found, then what are we going to do? We are going to fetch it from our DB, right? From a DB which we had seen earlier, right? Wherein uh, right, our NoSQL DB, right? Right. So wherein the key would be the short keys, right? The key would be the short keys, right? JKEL6EC, whatever it is. If it is not from the cache, we'll fetch it, we'll go and look up into the database, we'll fetch it, we'll fetch the long URL, and we'll also store in the cache, we'll also store in the cache that short and long URL, and then we'll return to the user. Okay. So this is the flow on a high level flow. This will be the flow. We saw that um, the writes will be separate from the reads so that the latency is minimum for the reads. Okay, like everything is the concerns, like this, there will be separation of concerns over here. Okay, so this is the high level system design of URL shortening service. We have seen the functional requirements, the non-functional requirements, the scale estimation, the API design, the database design, and the high level, the business logic, and the high level flow diagram. So this was the designing of URL shortening service. I hope you have liked this. Kindly like the video and subscribe to my channel. Thanks for watching.